While the idea of time reversal might ignite our imaginations, it's crucial to understand its boundaries in the realm of reality. Nothing does not refer to anything that could possibly or actually exist. In the same vein, time reversal doesn't refer to anything that could truly occur on a macro scale. Let's break it down with an example. Any event designated with symbol X, say an actual event in our daily lives, occurs within a specific time frame. For instance, event X begins at time t1 and ends at time t2. There's always a non-zero time duration between t1 and t2, making it a tangible, observable reality. However, things change dramatically when we venture into the quantum realm. Here, events involving the entanglement of quantum particles, like two electrons, defy our everyday understanding of time. These particles can exchange information instantaneously, regardless of the distance separating them. This mind-bending phenomenon known as quantum entanglement hints at the peculiarities of time on a microscopic scale. Yet despite these fascinating discoveries, time reversal remains a concept limited to the quantum world. Time is an invention of human consciousness, strictly limited to two domains: real clock and calendar time, and imaginary time. Furthermore, the arrow of time is the term coined in 1927 by British astrophysicist Arthur Eddington to describe the one-way direction of time. Eddington made original contributions to the theory of thermodynamics, and therefore also entropy, which clearly limits time to follow entropy, which is impossible to reverse, because heat exchange always moves in only one direction, from hotter to cooler objects hosted within some volumes of emptiness. Changes in temperature, entropy, and time are all congruently and coherently one way only. There has never been, nor will there ever be, any empirical observation that violates the fact that temperature, entropy, and time are one way only. This statement holds true at both the quantum scale and the macro scale. Whatever mysteries exist in quantum mechanics, they do not challenge the fact that temperature, entropy, and time are one way only, not reversible. However, not reversible has a different interpretation for temperature and entropy than for time. For time, not reversible is absolute, but for temperature and entropy, injections of energy into any finite closed system from outside that system can do the work to reverse the changes. But no injection of energy can in any way affect the one-way passage of time. If we inject heat into some measured volume of emptiness, that can reverse the previous transfer of heat between two volumes of emptiness, and injection of energy into some system can cause information to increase order, reversing some previous entropy disorder of information. There is nothing that can be done to reverse time. Every event is new, existing for the first time, never a reversal to any previous state or condition. The whole physical universe is, by common assumption in physics, closed to injections from outside, which permits conservation of total mass, matter mass and energy mass, E equals sign mc2. Conservation means that increases of matter mass and energy mass are necessarily offset by decreases elsewhere in the closed system. Decreases of matter mass and energy mass are necessarily offset by increases elsewhere in the closed system. There can be no violations to these conservation rules if the universe is actually closed. If the universe is one of many, a multiverse, there could, at least in principle, be exchanges of mass between them. But even then, there will be the same conservation rules for the multiverse. It will be closed in the sense that everything that could possibly or actually does exist is necessarily inside the multiverse. We do not have any physics that could describe what is outside even our known universe, let alone what could be outside a multiverse. Time reversal literally requires reversal of the total state condition of the whole physical universe to exactly, without the slightest possible deviation, some state condition that actually did exist in the past. Literally everything, leaving nothing out, must be simultaneously at some specific instant of present now real clock and calendar time, returned to a previous state condition. The idea that it would be possible to change some isolated detail to a past condition, say bring grandpa back to life, is incoherent, however well-intentioned and heartfelt that desire might be. If you could bring grandpa back to life, for instance, manage to restart his heart and breathing without mechanical assistance, that would certainly not be reversal of time. That would simply be a new event, which is for the first time ever in the flow of time. It would literally require changing the wave function for the whole physical universe, which necessarily includes changing laws of physics. However, it is by common assumption all laws of physics and all rules for the whole physical universe live, organism began to exist at the instant the universe began to exist all at once, and all those laws and rules are conserved. They will only cease to operate if the whole physical universe ceases to exist. Whatever changes occur are described with a set of Schrödinger equations, and they change constantly. Schrödinger equations are not conserved, rather they calculate specific values for variables, within the strict limitations imposed by the conserved wave function set of rules for the whole physical universe. Those rules must be obeyed exactly, only and always, or they would not be conserved. As we delve deeper into the nature of time and its irreversible march forward, we are not just confronted with scientific paradoxes and physical impossibilities. We also encounter profound philosophical questions that challenge our understanding of existence itself. If time cannot be reversed, what does this mean for our concepts of destiny and free will? Are we merely passengers on a one-way journey through the cosmos, bound by the unyielding laws of physics? Or do we possess the power to shape our future even if we cannot change our past? Consider the human experience of memory. Our memories are not perfect replicas of past events, they are reconstructions colored by our emotions, perceptions, and even the passage of time itself. This suggests that our understanding of the past is inherently fluid and subjective, much like the flow of time. Moreover, the irreversibility of time invites us to ponder the nature of progress. If we cannot return to a previous state, then every moment is unique, an unrepeatable part of the tapestry of existence. Our fears and our hopes, from the inevitability of aging to the finality of death, time shapes our narratives and our identities. Ultimately, the impossibility of time reversal underscores a fundamental truth. We are finite beings in an infinite universe, bound by the constraints of our physical reality. Yet within these constraints, we find meaning, connection, and the drive to explore the unknown. As we continue our journey through time, let us embrace the mystery and wonder of our existence. Let us seek to understand the universe, not just through the lens of science, but also through the richness of human experience. For in this quest, we may find that the answers we seek are not just about the nature of time, but about the nature of ourselves,